Good morning. It's my pleasure to introduce a very good friend, Chue. Neil and I met when I was part of Globus and he was part of Oxidai, and Oxidai was first looking at becoming part of the Globus toolkit. He's got his degree from University of Edinburgh and has lived there most of his life, I think. And currently, he is the director of OMI, which is a project in the UK that works with academic software projects and tries to make them more reliable and sustainable. He's going to be talking about his experiences with OMI and what has worked and not worked in that space in terms of sustainability for us today. So, Chue.
Thank you very much, Jen. Thank you very much, Brad. And thank you very much for everyone who's sitting in this room today at the, for me, the unseasonable time of 8:30 in the morning. I hope I'll keep you entertained enough with some of the tales of my experiences that you won't all immediately fall back asleep again, but if not, there's still plenty of coffee outside. So what I'm going to be doing is giving you a little bit of a background on something that's been happening in the UK, which I think is of relevance to the discussions at the workshop over the last couple of days. As Brad said, I've been in one of his sessions, and I think it's really interesting seeing the differences and also the similarities between what's happening in the US and what's happening in the UK. But before I started, I have this slide in that I normally put in, because when I go around talking to different people and talking to my friends, I realize quite often I don't really know what I do. So what is it that I do for a living? What is it that I bring to the table? And it's interesting. So I started off working with lots of small to medium-sized enterprises, trying to understand how to keep them supported. So how could we use technology to help in the breaded mushroom industry, for instance, which is very interesting now that we're heading towards a recession. I'm also involved in sustainable services. So this here is the oldest purpose-built union building in the world. So this is a students' union. It's also the third largest catering supplier in Edinburgh, where I live. And so one of the things that I have to understand is how do we ensure that we're keeping up to date with what people are looking for in different marketplaces. This is another of the things that I'm involved with. This is a wonderful little idea. It is a cinema on the back of a lorry. So this is probably the one that's coming closest to where I'm going to be talking about today, which is how do you create sustainable communities? How do you create pockets of activity based around seed funding? So here, in this case, we have funding to run this lorry which goes around the Highlands and Islands in Scotland. But the question is not how we plan that. It's how we plan for the community activity that happens after the lorry has left a particular village. And of course, this is what I'm going to be talking about today, which is this little team of people, which I lead, where we are talking about sustainable software and how we can ensure that what we create from the academic projects in the UK, which is of use to other communities, both within the UK and internationally, can continue going, can continue in its development, improve its sustainability, and ultimately improve the number and the happiness of its users. So, a lot of the discussion at this workshop has been sort of around what if. And some of the questions that have come up have been, what if there had been a large-scale cross-funder cyber-infrastructure initiative in the States? What happens if there was explicit funding for software development that was separate from the researcher review panels and was judged on the quality of the development and not on the quality of the research? And what if there was a group set up to take the software outputs of such a program and support its continued development? So, in the UK, we had the eScience program. So this is John Taylor, who was the Director General of the Research Councils, speaking back in, I think it's 2002, talking about how eScience is about the global collaboration in key areas of science, and importantly, it's the next generation of infrastructure that will enable it. So he put in place a program which embraced all of the different research councils in the UK and also brought in representatives from industry. So we had funding from both the Department of Trade and Industry in the UK and funding from various commercial groups, including people like IBM, Oracle, Sun, Microsoft, to try and bring all of these together to create a coordinated program of both research and infrastructure development. And it was a large program, and I have to thank here one of my past colleagues and ex-director of OMI for this slide, Steve Newhouse. So there was a lot of investment in this from all of the research councils. There was 213 million from the research councils, and that only covered staff costs. It didn't cover the hardware or the network or some of the travel. There was an extra 100 million put in by JISC, and there was another 25 million put in by industrial contributions. But the bit I'm going to try and circle, if I can work out how to use this laser pointer. Which one's laser pointer? Okay, not that one. Top button. There we go. All right. Is this bit here. So this is the core program. And the core program is what was put in place to effectively create a set of different sorts of cyber infrastructure. So different projects to create the base level software and applications for different communities that could go forward and create this new set of research methods, research groups. So in 2004, about 2 years after this program had kicked off, OMI was formed, the Open Middleware Infrastructure Institute, as was at that point. It was a joint effort between IBM and Southampton, and what it did was put in place a software engineering and QA process for the software that was being developed in these projects funded by the core program and the rest of the eScience program. It had an ingest pipeline, so what it did was it had a process for identifying and then hardening different pieces of software, and it had a managed program where different pieces of software were commissioned to fill in the gaps between the projects that were already developing infrastructure. It also was focused around middleware and created a middleware distribution which was WSI-based, and so for those of you who were involved in it this time, you will remember this is the point where we were having all of the wars as to whether or not it was WSI or WSRF or OGSI or any number of other competing standards. So that was a sort of first phase of OMI. What I'm going to talk about really, and my experiences, is how things changed in OMI, and also what worked and what didn't work from the two different phases of OMI so far. So in 2006, OMI got refunded, but with a slightly different remit. It brought on board more partners. So we had the addition of Manchester and Edinburgh, which is where I got involved. It kept the software engineering and QA process, but it started adapting it to fit better with the needs of the different types of software that we were beginning to support. It kept the ingest pipeline and this contributed program, but again, it changed the remit of this to look more about trying to help software go through the transitions that it needed to do to get to a sustainable and usable basis. And importantly, it moved away from being focused on the middleware and the software to being focused on the user relevance and adoption. And I think that's something that's come up quite a lot in some of the discussions, is about the difference between a top-down and a bottom-up approach. So effectively, we've tried both. I think also one of the things that we were particularly aware of is the need for collaborations and partnerships, both to understand what was happening in the UK and internationally, but also in recognition of the fact that we understood that we didn't necessarily have enough effort to do it all ourselves, and that we needed to work with different delivery partners to ensure that what we were wanting to do could happen. I think it's also of relevance to know that whilst funding is still very much on a national level, the way that science is being done now is on international collaborations. So we can't see ourselves as just being UK-focused, when a lot of our UK partners, a lot of the people that we work with to help with their software, have more collaborators outside the UK than they do inside the UK. So one of the other things that's been discussed is where we place the line for cyber infrastructure. And one of the things that we've been very keen to try and identify is how do you go between the different sort of types of user of cyber infrastructure. And in particular, we identify a distinction between people who we say are doing sort of the heroic research, the people who are on the cutting edge, the people who are driving forward the new research methods, the new results. Then we get the transition to the everyday research. So the people who are doing the bulk of the work that's generating the information that's leading to other sorts of discoveries. And then we go to the sort of production use. So as this drifts down, moving towards, for instance, the use of software within education, so within the graduate programs. And then finally on towards commercial exploitation, where we see the software being used not just in academia, but being used out in particular industries, or perhaps more generally, as has happened with some things, such as web browsers. And what we try and offer is a set of different services, I guess, that hit different types of communities in different ways. So effectively what we do is we do things to try and build communities. So here what we're talking about is really understanding how we can work with different people to create generic services that help lots of different communities. We provide what we call foundation services. So here what we are talking about is things like centralized help desks, centralized testing, and so on, which can be used by different projects to allow them to overcome particular issues, for instance, in terms of not having particular staff expertise. And we do responsive development. So here, identifying where the potential gaps are in the software infrastructure that's in use, and then trying to understand how we can fill those gaps, either by talking to funders to try and create programs, by doing evaluation of software and then the dissemination of how to use it, or by improving the standards and improving the kind of quality of the non-software development parts. So really, what OMI UK does really revolves around three different things. We support a whole load of different software. So we have, at any time, a varying portfolio of software that we support. Some of it is funded. Some of it is unfunded, but we provide, I guess, base-level services too, so helping with the outreach, the marketing, and so on. We provide sort of centralized support and help desk and QA functions, so helping people to try and outsource almost some of the things that they don't want to do themselves. And we do community engagement. So one of the things that we have been involved in is a project called Engage, funded by the JISC, where as part of 3 different projects, we've been interviewing researchers across the UK and trying to understand what are the barriers, what are the enablers, what are the things that are working just now, and what are the things that aren't working. And I think it's at this point that I want to kind of stop talking just about OMI and what it does, because otherwise you might get a little bit bored, and talk a little bit more about some of the issues now that we've seen from doing this kind of work, this community outreach work. And in particular, try and understand what the issue is that we see in the UK. And so I think it can be summed up really by two quotes that we've got. And these are taken directly from 2 of the interviews that we've carried out with different UK researchers. So one person, who will remain unnamed, said, "Sustainability is not an issue for CS researchers. We want others to take the software over subject to IP issues." Because they effectively were using software as a tool to do their research in as much as it was CS research. The fact that other people were using the tool and wanted to continue using the tool but weren't able to do development led to a bit of a paradox, because the original researchers who had developed this tool didn't want to sustain it, but other people did want them to. And that's really the problem, because another of the quotes that we got was that sustainability is a big issue. There were people who were producing complex tools that we want to continue to use, and it's not clear how they'll be sustained. And we saw this actually on both sides of the fence. So in some cases, the people who had developed the tools were wanting them to be sustained, but the users weren't. And in other cases, it was the users who were wanting things to be maintained, but the developers weren't. So we saw all different combinations of this. And I think one of the real issues is trying to match these two up. So at what point can we get to this happy medium of having people who want to sustain the software as well as the people who are wanting to use the software who are driving this? So what I'm going to do is really go through a set of different experiences about what I feel, I guess, about how we can ensure that the software which has users can be continued to be supported. And I think a particular thing that's of interest to me is how do we help software survive the transition between the different stages from creation to widespread use? So how do we help software at key points in its life? And I think if I can understand how to do this, then it would be great. I'd probably be a millionaire by now. So I'm not going to say that I've got all of the answers. I don't even know whether I've got any of the answers, but what I do have is some experiences. So what I'm going to do is try and talk about some of these and then see how these chime in, perhaps in questions with other people. So one of the things that I've discovered is that software development comes in stages and it takes time. So there are different stages in the development of software. You go from an idea, you turn it into a prototype, you may turn it into something which is of research quality and that you show to other people, your peers, your supervisors, etc., and they start using it. Then you realize that what you need to do is somehow start supporting the software because there are people using it, and then perhaps even be able to spin it out into a product and make some money out of it. So the original way that OMI was set up, the perception was what we would do is really target that bit there between research and supported codes, so this bit here. And what we would do is we would take codes that had been developed to the point where they were in use in different research groups and then turn them into something that would be able to be used in lots of different groups. One of the issues with that really is that I think my experience is that if you do it there, it's a little bit too late. Actually, what you need to be able to do is provide different input at different times. So you need to be able to provide input when you're turning from an idea to a prototype to check to see whether the design is right, whether or not there are going to be any issues with things like the architecture, and put in place things like the way that you're going to start doing testing. As you go from prototype to research, you need to understand issues of things like licensing and governance. How are you going to cope with these things when you get to the next stages of your software? And as you go from supported to product, you need to understand what's the overall sustainability model as you move away from being primarily research council funded to creating different revenue streams. So I think one of the issues is how do we identify the best points to place effort and what sort of effort needs to be placed at these different stages of software development. So one of the things that we do within OMI is called the Commissioned Software Program. And what this is it's interesting. It's somewhere in between, I guess, venture capital and a software foundation. What we have is a pot of money from the funders which we are able to allocate to different groups to do software development on pieces of software. And that's a really interesting idea. And I think it shows a lot of trust from the funders to be able to do this. And I think it also shows a recognition that you do need to be able to do this sort of small-scale impact funding to help software develop. And so really what it's there to do is, if you can identify what the gaps in functionality or quality are by talking to the community, you should be able to put in some effort to help overcome these gaps, so to cross those chasms. And so what we've tried to do is create processes for trying to understand how you make this an effective use of money. So we've kind of narrowed it down to 4 things that we tend to look for. One is the demand for the software understood? So do we know what is the marketplace that you're trying to address with this piece of effort? Can you increase the number of potential users by adding in this effort, putting in this funding? So you could do this in a number of different ways. So can you increase the number of users by taking it to a new domain? Can you do it by providing tutorial material and so on? Can you create a measurable increase in the research outputs from further developing the software? And that's often the hardest one. So how do you identify when there has been an increase in research outputs? And also, can you improve the community participation around the software? So can you put in place things that help people get more engaged and interact with your software? And so I'll talk more about that in particular later. So to give you an idea of what sort of size of projects and how many we're dealing with here, this is the kind of set of... I won't expect you to read the little labels on these, but these give an example of the different projects that, as they were at the start of last year, so about 1 year ago, and the sort of process where what happens is that we start off by providing some funding, so those are the things on the far right, and then we go through, we start providing some of the services to do with QA and so on as they're coming through that development process, and then we end up at the end where they're no longer funded, but they're being supported. And we typically, so this is what? Around just under 20, I think, different pieces of software that we were supporting at the start of 2008. And as we go through, the sort of software moves through this cycle. So there's this process that we apply to them to try and essentially improve the quality in some way of the different pieces of software. And they fall in lots of different categories. The ones which are in green there are really to do with computational stuff. Yeah. They do sometimes. So what I haven't shown is some of them falling off. So some of the ones from some of the initial phases of the program effectively have been end-of-lifed. So they may be end-of-life for different reasons. I can give you sort of two or three examples. Some have been end-of-lifed because the job that they were setting out to do has now been overtaken either by a better piece of software out there, and we would prefer to promote that piece of software, or because and typically it's to do with the sort of space that we're working in, standards. The standards have moved on, and so the way or the architecture has moved on. So the framework in which these pieces of software were created in no longer exists. So some of the things have disappeared there. Some get mothballed. So for instance, one interesting one is that there was a piece of software that's not on this list that was originally developed looking at monitoring of different sites within a large virtual organization grid. And that's effectively been mothballed because we've been waiting for the information services standards, which are now I suppose the main one that people may have heard of is GLUE 2. We were waiting for those standards to coalesce and for all of the discussion to go ahead. And now the question is it the right time to invest some effort to move that piece of software to the new standard and therefore make it useful again to the community? So yes, things do drop off the end. What we're trying to do really is ensure that as you move from the stages, the amount of effort needed to support it reduces. But obviously, even though the amount of effort to support things on the left is much less than the amount of effort to support things on the right, you can't necessarily support them all. Yeah, Dennis?
Opposed for selecting pieces that enter from the right?
Right. So We do. Part of it is based on this criteria here. The other part of it is to do with a number of other things. So in more detail, you can find out more about it on our web pages, but it is looking at things such as what are licensing restrictions, what is the current community support, how is the software looking to kind of target the requirements of the community and so on. So it's based around these 4 categories, but it goes into more detail about the different ways in which these categories might be represented at the different stages. You had a question there?
So if you go back to your chart there, it would seem that one of your challenges is clear gates to migrate this along. And how often do you find yourself at a place where you're not clear what stage any of those initiatives are, and have you been able to refine those gates over time?
I think it's easier for us to identify the gates between developing, evaluating, and supporting, because in some sense that's a gate that's applied by ourselves and the developers of the software in conjunction. The hard one is the gates between where we think we are in this cycle of sort of prototype to research to supported to product, because their opinions may vary, and in particular, opinions may vary from different communities of users. So, for instance, one community of users of a piece of software may consider that it is actually of good enough quality for them because they're used to the way of using it, and others may consider that it isn't. And so, particularly, we've seen this, for instance, for some of the things where we're changing between communities who are used to command line interfaces and those who aren't used to command line interfaces.
Don't you find yourself in a situation where they're in multiple of these stages at the same time based on the iteration of that individual project?
Right, and so you also find that it's effectively cycles, yes.
I guess the problem that I've seen in this type of model is that it doesn't cycle on a predictive basis, and in fact it isn't cycling so that it's at one stage or the other. It's actually at both at the same time.
Right. No, I think I agree with that. It also depends, I guess, on the particular software. Some software is more discrete, and you can see it going through the stages more easily. Other pieces of software, it's harder to see. So maybe I'll have some examples later. This is something that we've been trying to do to identify impact. So one of the things that has always perplexed us is how can we prove to our funders and the community what impact particular interventions that OMI might do would have on a piece of software. And so here, this is a piece of software which has been running for quite a long time, the GridSam job submission service. And what we've tried to do here is create a set of slides. Again, I don't expect you to see all of the detail, but I'll try and highlight some things to show the different stages of its lifespan and where it's had support from us and also what's come out of the different pieces of support for us. So we're trying to create these sort of timelines for the different pieces of software to identify how it's going through these phases. So effectively, what we have is we have something where at the start on the left here, it's really going from the idea to the prototype. Then as it's moving further forward, at this stage here, this little diamond, what we had was both an identification of a new standard which we saw having community support, and as such, a period where we started funding some development of this piece of software because it looked like it matched what was needed in the community. And so what we've got is a whole load of phases of project which have been funded by different people, but it's the same piece of software. And that's one thing that's interesting, is that effectively you can't consider it necessary to be one single project, but you can consider it to be one single product. And so moving towards the end, the interesting thing as we get to the end is that the development is not, so up until this point here really, all of the development is by a single institution, and then post this bit, we start having multiple institutions. So at this point here, we've had a bit of a jump, a phase transition. So that's the releases now. I won't bother with that one. So the other thing we can do is then identify what's happened as a result of that, and see whether or not, for instance, we can identify publications. So again, looking to see whether or not, and this is where it always becomes difficult in trying to track down citations, we can see whether there have been any publications that have been enabled by particular improvements that have been put into the software. This is much easier for functional improvements. It's much harder for non-functional improvements. And I don't think we yet have a good way of showing to our funders the direct impact on research outputs from non-functional improvements. I think that's something that we need to work on. And so in this case, one of the interesting things, again, for looking at how software is an international beast, is that now, at this far right here, with some of the improvements we did around about here, our major users of this piece of software are not in the UK, they're in China. We have, I think now, across about 2,000 nodes deployment of this software in China, but only across around about 200 in the UK. So it's an interesting mix. So the other thing that we tend to do there, so following on from that particular project, we work on the adoption and trying to roll things back in. So there, as you said, there's this cycle. And so in this particular case, we both funded the development, but then we've taken on board ourselves trying to roll it back into the community and understand how we can increase the number of different contributors to this. And so again, it's a cycle not just of software development, but of software adoption. So here we're working with one particular institution to try and help them to effectively provide a service to their different research computing users, and on the basis of that, understand how we can do it again at other institutions. So here we're starting off with University College London, and then moving towards the Northwest Grid, Edinburgh, and King's College London. And then that supports other projects. So here is something that we're doing with King's College London, which is much earlier on in the stage. So this is funding for a different stream of money that we have to try and support, I guess, taking something from an idea to a prototype to try and create diverse new methods in newer communities. So here we're looking at new ways of bringing together the information held in different databases across the world for looking at commentary on different sorts of Greek and Roman texts. So there is this cycle of development that goes round, and I think the thing that we've realized is that you need to be involved in all stages of it to have an impact, because everything is connected. The improvement of one piece of software triggers an interest from another group somewhere else, which needs to be supported by another mechanism so that you can go back round and eventually get more and more users on board. Okay, so one of the other issues that we've discovered is that there isn't a single best model for sustainability. We've toyed with different things. We've looked at what's been coming up in the literature through the years and tried to see whether or not different things could be applied. And I think the experience we've had is that there is no one best model. It depends on the piece of software. So earlier on, one of the things that we were often told is what OMI could do is it could act as the Amazon for UK eScience software. So Amazon works because it exploits the long tail. It knows that although there are some products which are very, very popular, there are also a whole load of products for whom there are at least a few people out there who want it. So given large enough availability of choice and a large enough population of customers, you can get this sort of curve which you can exploit. And so in eScience, we certainly have a large enough availability of choice. Particularly if we look at things like data storage and workflows, we have a supreme amount of choice there. And we have a large enough population of customers. But we don't think this model works simply because it assumes that there's a negligible stocking and distribution costs. So books have a long lifespan. You can store them in a warehouse, and it doesn't cost you very much. What we discovered is that if you try and do this with software, it stagnates too quickly. It stagnates within 6 months. Some of the software that we work with, which is in the more mature area of sort of video conferencing tools, we did a study there and identified that it takes, on average, about 6 months before something changes in the environment that needs to be fixed. And it's something that changes to the point where the software becomes unusable. So the long-tail in software doesn't really work. The other thing that we often get told is, well, why don't you just help everyone create open source software? Because open source is the way. And you'll hear, obviously, open source is free as in speech, or is it free as in beer? Which is it? And some of you may have seen this next one. A lot of people in the industry say it's free as in puppy. So this is something that's very difficult to get across to people, because particularly I think there was a stage in the cycle of who was kind of making the decisions that said, well, no, open source is the right way forward. And the thing is, it's not the wrong way forward, but it does have some drawbacks that need to be identified and managed. And I think particularly that last bullet point I put up there, that many are left abandoned by their owners, is very true. Open source is not simply about abandoning it to some mythical community of developers who in their spare time after work will contribute to your code. So how am I doing for time? So one of the things that we've tried to do is understand a little bit more about how we can overcome these sort of quick fix models, and understand a little bit more about how different people see the landscape from their different points of view. So one of the things we did, and there's a link to the report from that at the bottom of this slide, is run some workshops trying to bring together different sets of people, so developers, PIs, managers, researchers, funders, and bring them together into workshops, split them back out into groups, and ask them to answer different questions, particularly about how you think e-infrastructures could be embedded into the research process. So these are the questions we asked the different groups, and these are the sort of summary of the results we got. The interesting one is this one here, 4, trust is important. And I think that's the one that was highlighted more often than any of the others across many of the different groups. Trust is vitally important. It has to be said that most of the ways in which we understand how to use software, how we choose software, are based on trust. So we will tend to use a piece of software because someone else has told us it's good, because the documentation or the testing or the architecture looks good for us, depending on, again, what we place our trust in. We also will tend to choose software which is going to be supported in the future. And I think one of the interesting things that came up is that people would tend to pick a piece of software, and I won't say what the piece of software, the two pieces of software were that we were comparing. People tended to pick the piece of software that wasn't necessarily good at the time, but showed progress and showed that that feedback was being taken on board. So the comment that was made was that someone had chosen this piece of software over another because even though the other piece of software did 80% of what they wanted, they could get no feedback from it. They couldn't see whether or not it would still be available in a year's time. The other one, in their words, was terrible at some things. It was really difficult to use. It had no documentation. But they could see the improvement, and also they could see the assurances that they'd been given that there was funding for this particular piece of software for the next 3 years. So trust is a very important thing in creating software sustainability, and it works both ways. So in this particular case, it's an odd paradox. The software was trusted because it had a longer funding timescale, but it can't get that longer funding timescale unless it's used by the people. So which one comes first? Okay, I'll skip over this one, but this is an interesting thing. So I just noticed a couple of weeks ago, the 451 group, who do various kind of reports and policy documents, have attempted to classify open source business models. So that may be of interest to some people. What I've tried to do is classify some of the sort of sustainability models that we've seen. This was originally part of, again, another workshop that we did in the UK funded by JISC on business models for sustainability. So looking at the different ways in which we could support software in the UK. So the first model, which probably a lot of you use and are aware of, is what I call the grant mosaic model. It's basically where you try piecemeal to get as many different grants to support your software as possible. You carve out little pieces of your research grants to develop the software that you know is needed, but that you can't get funded separately. One of the things that we have in the UK is the idea of flagship codes. So there are some codes for which their importance is so high that it makes sense just to fund them as flagship codes. So we have things like called collaborative computational projects, and what they get is long-term guaranteed staffing at a low level to handle particular flagship codes. We talked, I saw some things in the talk test about institutional support. So can we get to the point where you get something which is of so much value to the reputation or income of a institution that it's willing to provide support there. So things like subject repositories, perhaps, and things like connections, which I've just started using. The one that I'm interested in, and I don't know whether it will fly in the UK, and I don't know whether it would fly in the US, is what I've called the fully costed model. So in the UK, we have our main HPC resource is called Hector. And one of the things it does is provide distributed CSE support tokens. And this is an interesting concept that basically means at the project proposal level, you put in for a certain number of tokens which can be redeemed when your project starts for software development by another person. So in this case, it's NAG, who have a team of people for whom you can spend these credits on. So they work with your particular codes to scale them, to create extensions and so on. And you can buy the support, but it's costed in at your project time. Can you imagine what would happen if the same thing happened in other research project grants where they said, what we'd like to do is buy research software development tokens so that I can have that fixed to my proxy added as part of my grant. Or more importantly, you can get a number of software tokens that don't necessarily specify exactly what needs to be done because you might not know about it, but will be there for you to use at the point where your project needs it. You get models like mixed enterprise and consultancy where you can do one of many things. You can either try and provide, you can try and get extra income by doing the bits that people want customized, but are relatively tricky to do. And you can do something where you license people to say, these are approved kind of like collaborators. Why don't you try starting to collaborate with them and placing your project grants with them? So starting to create a community of people who are good at working with particular code and then suggesting that different other research projects collaborate with them to act as the software development expertise. And you can try and create a foundation. And there was some very good messages put out by Brad yesterday on what it means to create a foundation and how that might work. The one that's not been explored yet, but I think we should explore, is the T-shirt model of open source. But I haven't yet managed to work out a way of making that work. I think what we are obviously failing to do is have enough cute or kind of like cartoony images in our software that means that people would buy the T-shirts. So let's see. I'm starting to run out of time, I think. So I'm going to try and skip through some of the slides. What I wanted to do was highlight a few different things. So one of the pieces of software that we've been working with for a long time is Taverna. Taverna has been funded through a number of different ways. It started off being funded through an eScience pilot project, the Migrate project. Then it got direct funding under a software stream through OMI UK, which included additional unfunded effort for doing things like marketing and outreach and legal and networking. And then it's also got platform funding. So what's happened with Taverna is it's managed to create a series of different grants that have helped support a core team and created that kind of trust. And as a result, it's now able to supplement things in different ways. So Taverna has a subcontract with the CA Big project to do different things. Not necessarily work on the workbench, but work on the provision of services that can connect into the workbench that are specific to CA Big, as opposed to the bioinformatics community that Taverna was originally developed under. And it also has a contract with Eli Lilly to try and do some development that will be of use to them. So here, because it's got that platform funding, it's able to go out and try and get this additional funding and eventually, hopefully, transition to something which is very much a model of having sort of some core grants and also several consultancy grants that try to improve it in different ways for different communities. Another project in the UK which has had an interesting thing, and here I think what you said about the overlapping cycles is interesting. Here a pilot project started off in the aerospace industry. It then got picked up under trade and industry funding to do something more in that industry. But it was noted that one of the particular tools that was being used, the Signal Data Explorer, could be used in other domains, and so it got funding again from a completely different source to be used in neurosciences. So you've got a tool that was originally used to try and identify vibration problems in aircraft engines being used to identify problems in neural pathway signals in the brain. So here's an example of something where actually the sort of stage at which a piece of software at is very different depending on which community it's in. So, $5 million question that I'll ask about sustainability is one of the issues that I'm always coming up against is the difference between software sustainability versus staff sustainability. And it's a very hard bullet to bite on. So one of the things that we have to understand is it more important for us to keep the software going, or is it more important, or do we actually believe quite rightly and quite selfishly that we want to keep our staff going? And that's a very difficult one to overcome. The other thing is really, why get a grant for $3 million that builds on someone else's software when you can get a grant for $5 million to build your own and then steal those set of RAs who are building the software to do the research you want it to do? So again, why get into the software business? So it's a very difficult one to get out of. Okay, so now the last stage of it. The last thing I kind of want to say is increasing participation is, I think, the way that you get long-term sustainability. It's the thing that I've seen from working with the other communities. I think it can get transferred to the software community as well. The question is how you can help do that. So, you'll have heard this wonderful thing saying, give a man a fish, you feed him for a day, teach a man to fish, and you feed him for life. So how do you create a larger active set of users, a set of people who are involved in the development of your software? And to create these kind of communities, you typically need to look at 4 things: cohesion and identity, tolerance of diversity, efficient use of resources, and adaptability to change. So how can you transfer those ideas, which have come out of the ideas of trying to create sustainable communities in terms of agricultural economics sustainability, and do the same thing in software? So a lot of these have almost direct analogies in the software space. So cohesion and identity. Do you understand what it is you're trying to do with the piece of software and who you're trying to do it for? Tolerance of diversity. Can you ensure that the different inputs you're getting from the different communities can be taken forward in a way that is going to really benefit all of the communities? Or can you say to people, that's great, but not just now? Efficient use of resources, and this is coming back to trying to understand how to make it easier and simpler to maintain and to develop your code. And adaptability to change, because like it or not, we do not live in a stable software environment. Things are changing all the time, and I think one of the things that we need to understand is that we can try and keep things as stable as we can, but things do change. The corollary of this saying is this one. If you teach a man to fish, you introduce another competitor in the overcrowded fishing industry. If you give a man a fish, you stimulate demand for your product. So I'm not sure actually that I'm doing the right thing for all of you, and perhaps what I should be saying is ignore all I'm saying, just go out there and get the grants, and then overdo it. So I'm going to skip through some of these slides. The thing that we've got to try and do is get rid of some of this thing called participation inequality. So some of you may have heard of this as the 90%, 9%, 1% rule, where 90% of people are effectively passive participants. They're along for the ride. So, for instance, it's been applied to teaching. So 90% of your class, 90% of the people that you're talking with are, they're just there because they have to be. 9% are the people who are nodding along, kind of like going, oh yeah, no, what you're saying is really good. And then there's 1% who are really actively asking questions. And I'm not going to say whether I think you guys are following the same pattern or not. The question is, how do you help push the people up? Now, one of the odd things is, if you agree with this rule, you'll see that there's probably only one way of improving the number of creators and editors, which are equivalent to kind of like the contributors and the active users to a piece of software. And that's by getting more people in at the bottom. So really, I think what we're trying to do to create sustainable software is ultimately growing the number of users. So that you have a larger number of passive users, a larger number of active users, and a larger number of contributors. And so there are different ways of doing this. I think one of the most important one, and sorry for having to flick through these slides very quickly now, but they should be available on the wiki, is to improve the availability and visibility of both the software, but also the success of the software. So try and find different ways that you can show things working. You also need to be able to support people as they make the transition. So if people are wanting to move from being a passive user to an active user, can they do that easily? And so there you need to try and target what's required, what will both allow someone to make this jump and also keep them there. So you might need to improve things like the APIs, the contribution process, and so on. So in this space, interoperable standards are the interesting one, because if you can create standards for doing communication between software and standards for particular places in your software where people might want to extend it, you increase the ability of people to make that jump from being a passive user to an active user. And so finally, I guess, I'll mention this very briefly. One other thing that you can do is you can try and do something where you do something slightly different. So one of the things that OMI does that is taken from industry is having a set of people who are our eyes and ears in the community. So what we do is we provide them with funding for travel, and we give them some priority access, and in return they report back. Now, this is an interesting thing because it circumvents a whole load of different issues with trying to understand. These are the people who've shouting out about what's both good and bad about our software. So let's have them on board as well and try and create more people. So these are the people who go out to the specific conferences, the biology conferences, the astronomy conferences, and so on, that we can't go to because we don't know what they're talking about, and talk knowledgeably about how the software works in that area. Yeah. Okay, 6 here. So the 6 people. There's 6 people in the domains. So Mark Wilkinson there is someone who is in the clinical and biosciences domain. So he's based in Canada at one of the hospitals there. Chris Higgins is in the geospatial data delivery. Isao Kojima is in Japan, and he is in information management, effectively. Marco Roos is, again, in the bioinformatics community based in the Netherlands. Matthew Pocock is one of the open source proponents, and he's based in the UK. And Ravi Maduri is from the US, and he interacts in a number of communities, but primarily CA big just now. So we have a spread of different people, and these have changed. We've had other people come in and out. The appointments are on a one-year renewable basis. Okay, so just to finish off now, I'd like to kind of like throw a spanner in the works and pose some questions for later. One of the things that I'm starting to get increasingly worried about is, can we still consider traditional notions of software? And so I'm going to give you 3 examples very quickly. One, this one's very dear to my heart. This is Edinburgh, where I live. And what this is a map that's been created using publicly available data to answer a specific question, which is, at what points in Edinburgh is it quicker to use public transport than driving? So those kind of bright patches there are where you should live based on the publicly available data, where it will be quicker for you to go by bus than it will be by car. Now the question is, what's the important piece of software here? This is clearly a great result to use, and it's reusing data. But what's the important piece of software here? Because the actual piece of software that created this is very simple, and also it's very throwaway in that this only works for one particular place. You actually would create variations of this software for other places. So what's the important piece of thing to sustain here? I would argue that you're trying to sustain the data, and you're trying to sustain the way of asking the question here. So here's another one. Some of you may have heard of My Experiment, which is a UK-based project which allows you to save, well, anything, but primarily workflow artifacts. So here again is, what's the important thing to sustain? Is it the pieces of software that are referred to by these little blocks here, or is it the process of knowledge of this workflow that allows you to identify how the problem was solved? Because we're always going to have software decay, and one of the things that we've done at OMI is create something which is a workflow decay monitor, so identifying when a workflow can no longer run. And again, does that matter? Because in many of these workflows, the particular block here could be replaced by another service put up by someone else, as long as you know what they do. So what's the important thing to maintain there? And lastly, a depressing one for all of these people who've been talking about Facebook and Twitter and so on about sustainability models. How many of you have heard of something called Mob Wars? Yeah, few people. Okay, Mob Wars is a Facebook application, and it's moved towards being a iPhone application and so on, and it's got a great sustainability model. It's got last October, after having been launched for about 9 months, it had 2.5 million active users, which is huge. It was reckoned that if it trailered something, it had a better impact. So if it was trailering a movie or something, it had a better impact than putting something on all of the movie theater screens in America at the same time. And it had, at that point, a turnover of $1 million a month after only 9 months and maybe 4 point releases during that time out there. And how did it do it? It had this business model where you paid for respect. So you could either do well in the game by working hard at it or by paying for it. And as the whole point was to try and beat your friends, paying for it in small increments of 50 cents and $1 became very, very popular. And with 2.5 million active users, all paying $1, that's a lot of turnover. So here's a question. If you were to look at a radically different funding model for research software, can you exploit the fact that now people, particularly the people who are coming up into the university classes now, have a radically different way of how they communicate with each other? So there we go. I'm going to finish on that. I'm going to say thank you very much for listening to me. I think one of the things that I've tried to bring out in this presentation is, how do you build communities around software? And is that the right way of doing it to create sustainability? And also, is the right thing to do to create a body or a set of organizations which are at an objective distance from the actual producers of the software? And so I can't claim that we've necessarily got everything right. I hope that we've not necessarily got everything wrong. But hopefully in some, if there's time for questions later on, or catch me at the break or lunchtime, I can answer anything more specific. So, thank you.
it. You want to take one question while we're transitioning to get Cliff up?
So you mentioned something about happiness in the beginning.
Mm-hmm.
Now, can you briefly comment on what is this happiness index doing with your models? I mean, with various factors here. I mean, you of course described about audience qualities and levels, and maybe you can use that as a basis.
Okay, so in terms of the happiness question here, you're talking about the happiness of users in the community or the happiness of the developers? Okay. Right. So I suppose that's always the hardest thing to identify is what is it that makes people happy from a piece of software, and so in particular understanding the different ways in which different things will make different sets of people happy within a community and how you can balance these. So for instance, in one of the pieces of software that we're developing to do with the axis grid, the key issue is, does it make people happier to have something which is as similar as it can be to software they've already used, despite the fact that that software isn't necessarily the best user interface, or is the best thing to make people happy to create a new interface that resolves some of these problems? And so for some of the community, they actually want something which is identical because they're very familiar with the way that this is being used. For others who haven't come from the same background and haven't used the previous piece of software before, they prefer something which overcomes this. So there are different ways that you can maybe define the happiness levels of the users. And then the issue is how you manage to bring all of the different requirements together and prioritize them. I don't know if that answered your question.
No, I'm asking generally, what is over a period of time, who's happy, who's not happy, who's sad, and what is the problem?
Oh, okay. I'm not sure I can answer that. I think that's one that I'd have to throw open to the discussions as to whether or not I understand whether I can see a happiness trend, whether people are getting happier overall.
Happiness is too different.
Yeah.
Satisfaction is
right.
What is better.
Yeah. So in terms of satisfaction, I think that's easier to measure with satisfaction. And I think the easiest way of understanding how the satisfaction levels are going about, there are two ways that we would use, formal and informal. So formally, through the community outreach and engagement, things like going through and doing interviews, participating in project meetings is very useful for understanding satisfaction levels. Informally, the best way of understanding satisfaction is at these project meetings, going out and offering to buy people drinks to say what they're not satisfied about. And there we've picked up the most information about what makes people satisfied and what doesn't at a particular point in time of software. And interestingly, one of the things that you have to overcome, I talked about this 99-1. The problem that you have is that the 90% of people who fall into this passive users, they won't say anything more to anyone else about what made them unhappy. And if we hadn't gone and talked to them in the bar, they wouldn't have said anything. They might have said something to their PI, but their PI would have probably been along the lines of, this software is terrible, we shouldn't use it. Rather than, this software has a problem handling job sizes of larger than n in the conditions of this sort, which can be fixed. But I think that's the way that we try and measure satisfaction, is by asking people.